Today we are going to learn again probability. The question I take from Nilam Module PAK 21. We look at question number 1. Diagram 1 shows two spinners. The student spins the pointer in spinner 1 followed by the pointer in spinner 2. By listing all the outcomes of the events, find the probability that A. Both pointers land on the even number. How we write the outcomes, how we list the outcomes. Normally, I will ask students, you draw a simple table. Okay, the vertical column here, we write spinner 1, 1, 2, 4, 7, and 8. So we write all the number in this column. For the second spinner, we have number 4, 11, 12, and 9. So let's say the first pointer land at 1. And second pointer land at number 4. So we have the outcomes 1, 4. Maybe the first pointer at 1 at the first spinner and pointer land at number 9 at the second spinner, and maybe it's 1, 11, 1, 12. We just list out like this. Okay, so maybe it's 2, 4, 2, 9, 2, 11, 2, 12. Okay, here first number is 4, so I write 4 first. Okay, first number is 7. Maybe write like this faster. And first number is 8. After that, I write the second number here, all 4, right? 4, 4. Here 9, 9, 9. Second number 11, 11, 11, 12, 12, and 12. Okay, so now I list out all the possible outcomes. Now, A, both pointers land on the even number. Based on the possible outcomes here, we check which one we have even number. So second row here, 2, 4, we circle it. 2, 12, 4, 4, 4, 12, 8, 4, and 8, 12. To list out all the outcomes first. So what is the outcomes here? First one is 2, 4, 2, 12, 4, 4, 4, 12, 8, 4, and 8, 12. Okay, so when you list out all the possible outcomes, you need to write in set notation. So use this bracket. Okay, so after you list out, only you find the probability. So now, how many possible outcomes here? 1, 2, 3, 4, 5, 6. So, equal to 6 over, okay. So the sample space here, total possible outcomes, how many? So here 1, 2, 3, 4, 5. 5 times 1, 2, 3, 4. 5 times 4 is 20, right? So 6 over 20. Okay, don't forget to simplify it. Here divide by 2 is 3 and divide by 2 here is 10. Okay, so this is 2 marks question. So here when you list out the possible outcomes, you will obtain 1 mark. And after that you write the probability here, you get another 1 mark. Okay, now B. Pointer in spinner 1 lands on an even number and pointer in spinner 2 lands on a prime number. Okay, so the keyword is n. Means you need to find even number and prime number. Okay, so first spinner, even number. Second spinner lands on prime number. So first spinner here, even number. So even number, and even number. Okay, and second spinner lands on prime number. So we go to these 3 rows and we find which one the second spinner lands on prime number. So here, even number for spinner. Second is 4 not a prime number. So we cannot choose this one. 9 also not a prime number because 9 can divide by 3. Okay, I hope everyone know what is prime number. Prime number is the number that only can divide by 1 and itself. Okay, so 2 and 11. 11. Okay, so for here, add here, we have add 11. Okay, now again, we need to list out all the possible outcome. So 2, 11, 4, 11, and add 11. Okay, so you obtain 1 mark here. After that, write the probability. So possible outcomes only 3. So 3 over the sample space is 20. Okay, so you obtain another 1 mark here. We go to question number 2. Okay, so now question number 2. Diagram 2 shows 5 alphabetical cards. Here we have P, R, O, P, and S. 2 cards are chosen at random. After 1 card is chosen, the card is put back before choosing another card. Okay, so means that this one is independent event. Take out 1 by 1 and without replacement, that one is dependent event. Okay, so when we draw the table, you see, first card take out here. We have 2P here. That's why we label here P1 and here is P2. We cannot say we have 2 letter P, so we write 1 time, cannot. So you just label it P1, P2. Okay, so P1, R, O, P2, and S. And second times, because the card, after you take out the card and you put it back. That's why second times we still have P1 in the box, R, O, P2, and S. And the card can repeat. So you can write P1 and P1. This question, because the card is put back before choosing another card. So you cannot put dash. So this is P1, P1. Okay, so P1 R, P1 O, P1 P2, and here P1 S. And you can do it. So now here is R, right? So here is the first card take out. So I write it like this. Maybe it's faster. Okay, first card R O P2 S R O P2 S R O P2 S R O P2 S. So here, second times all P1. So I write down P1. Here R. Here O. And here P2. And here is S. Okay, so after you complete the table here, now you answer the question. Okay, by listing all the outcomes of the events, find the probability that A, the first card is alphabet R and the second card is alphabet S. So R followed by S. So we have how many cards? First card is R. First card is R is this part, right? So R followed by the alphabet S. Only one, right? Only list out the possible outcomes. R, S. Okay. So the sample space here, total of the sample space, 5 times 5. So 5 times 5 equal to 25. So only 1 out of 25. So the probability is 1 over 25. So here 1 mark. Answer here another 1 mark. Okay. This is B. Okay, now we go to B. Both cards have the same alphabet. Okay, so same alphabet we have PP, P1, P1, RR, OO, P2, P2, and SS. The same alphabet here. From here, we still can find P1, P2, right? Same alphabet. Any other? P2, P1. Need all together. 1, 2, 3, 4, 5, 6, 7. Right. We have 7 possible outcomes. 1, P1. P1, P2. R, R. T2, T1, T2, T2, and S. Okay, 1, 2, 3, 4, 5, 6, 7. Means the probability both cards have the same alphabet is 7/25. Okay, we go to question number 3. A box contains 10 apples. 3 of them are rotten. 2 apples are selected randomly. The diagram in the answer space shows the incomplete possible outcomes of the event. Complete the possible outcomes of the events in the diagram. Find the values of S, Y, W, and Z. Okay, so now here, this is a tree diagram. We learned it before, right? Okay, so for tree diagram, you must know when this one fraction of this one combined with the fraction of this part will equal to 1. The value of S, you must 1 minus 7/10 or 10/10 minus 7/10. So 10 minus 7 equal to 3. So here is 3, 10. Of Y is 2/9. So that when you add it will equal to 1. Okay. Good condition. Second apple rotten. So what is the outcomes here? Here is E, R. Okay. So here, first apple rotten. Second apple in good condition. So R, E. Then first apple rotten and second apple also rotten. So R. Using the complete outcomes in A, find the probability that 1. A good apple and a rotten apple are chosen. So one of the apple is good condition and another one apple rotten. So here both good, so cannot choose. So here, yes, we choose it. One good apple and another one rotten apple. Or here also we can choose one rotten apple, one good apple. And here to obtain a good apple and a rotten apple, or we also can have probability of a rotten apple and a good apple. To choose a good apple here, first time is 7/10. Keyword is n, so you multiply. So second one, R is we take from here, right? So 3, 9. Okay, if the keyword is or for probability, you add it. Okay, so this is the first probability E and R. Okay, now plus probability obtain R here is 3/10. So 3/10 times here 7/9. Okay. So when you count it, what you will get 1 over 15. We discuss B2. At least one good apple are chosen. Both apple in good condition, of course, we can choose. Here, one good, one rotten, right? One rotten. So this one also we can choose at least one good apple, right? So here also can. Here both rotten already, we cannot choose. So how to write this one? Here, actually we have two methods. I show you both methods. Okay, means probability. You choose first is good apple, second also good apple. Or E, good apple, and the second one, rotten apple. Or you have another one. First you got rotten apple, after that you got good apple. Can be like this. Okay, you must know E and E means multiply. So here, EE, how to obtain EE? 7 over 10 times 6 over 9. So 7 times 6 over 9. Okay. Or, the keyword or means plus. Yeah. ER. Where is ER? ER. So it's 7 over 10 times 3 over 9. Okay. Plus RE. RE. So 3 over 10 times 7 over 9. Actually quite simple. If I show you the tree diagram already, you just remember the keyword for n is multiply and the keyword for all you just plus. Okay, into your calculator, you will obtain 14 over 15. The complement of probability. Okay, so means here 1. So 1 minus the probability, you get both rotten apple like this. Okay, so 1 minus first R is 3 over 10. Second times you got the R is 2 over 9. Okay, so equal to 1 minus 6 over 90. Then you simplify it, you count it, you will get also 4 over 15. Okay, so both method we can accept. Okay, 4. A coin is tossed and a dice is rolled simultaneously. Okay, means at the same time. By listing all the possible outcomes of the events, find the probability that a head and an odd number are obtained. Okay, coin and dice, the outcome of coin is head and tail, and the outcomes for the dice is 1, 2, 3, 4, 5, and 6. So when do it simultaneously, means you at the same time head for the dice you get number 1. Or maybe you have head and number 2, head number 3, head number 4, head number 5, and head number 6. Okay, here maybe tail and 1, tail and 2, tail 3, tail 4, tail 5, and tail 6. Any of the possible outcomes of the events, find the probability that a head and an odd number are obtained. Okay, a head and odd number. Quite simple, right? Just circle it and you list the outcomes. Hedge 1, hedge 3, and hedge 5. 3 only, right? Okay, so what is the probability to obtain a head and an odd number? Here, possible outcomes 1, 2, 3. And the total of the sample space is here, right? So 1, 2, 3, 4, 5, 6, 6 times 2 here is 12. Okay, if can simplify, we just simplify it. So divided by 3 is 1, divided by 3 is 4. So 1 over 4. Okay, now tail or a number greater than 3 are obtained. Okay, so the keyword is or. When the keyword is or means can accept either one. A tail, you've got a tail or accept. Here, all can accept. Or a number greater than 3. So here, number greater than 3, we cannot include 3. So understand or not? If all means a lot of possible outcomes. If n, make sure both criteria fulfill, then only you choose it. Okay? So now possible outcomes. How many possible outcomes here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, a lot. So I write hedge 4, hedge 5, hedge 6, T 1, T 2, T 3, T 4, T 5, T 6. Okay, so just now how many? 9, right? So 9 over the total of the sample space is 12. So we simplify it equal to 3 over 4. Actually, for video, please feel free to like and subscribe to my YouTube channel. Thank you.